I'll make this the main video so you can all see it. Right, so we've got the addition and subtraction. Right, so let's see. The first kind talks about finding the exact value. And it will be find the exact value of a sine, a cosine, or a tangent. But the angle that they give you will not be in the unit circle. So if somebody said find the exact value of the cosine of 45 degrees, I'd go to my unit circle, I'd find out what the x coordinate was at that particular angle, and it'd be √2/2, and thank you, nice question. Now, we're going to get things like this. Find the exact value of 75 degrees. It is not on the unit circle, as I said. The way that you do this is step one, is you find two angles that either add up to 75, or if you subtract one from the other, you get 75. And I don't just pick any old two angles. I don't just say 60 and 15, or 33 and 42, because they wouldn't work. The last part of the puzzle is that these two angles, both of them need to be in the unit circle. So you've got a limited choice. In fact, very often there's only one choice, one combination of two things added that give you 75, or two things subtracted that give you 75. Has anybody got a thought of what kind of combination that would do that? Two numbers in the unit circle that add to 75 or subtract to get 75.
Of what's in the storage room in paper form is not in.
Okay, I can hear someone talking, but I didn't catch what they said, so they may have been giving me the answer. So I'll try that again. Was someone volunteering the answer to 75 degrees?
Would it be 30?
Yes, I heard 30, and then I think I might have cut you off, and the other's 45. You see those two numbers add up to 75. Now, if you think of the unit circle, there's not an unlimited choice, isn't there? I mean, there's 120, there's 45, and so on. Now, once you have figured out that, you're then going to use a formula. And the formula says that the cosine of A add B, or alpha and beta, whatever the book decides to call them, is the cosine of A times the cosine of B, take away the sine of A times the sine of B. Now you look at those guys there. What I've done is I've taken 75 and split it into two fellas. This formula is essentially saying call this one here A and call this one here B. So I'm now going to be able to get the exact value. It's the cosine of 30, the cosine of 45, plus the sine of 30 times the sine of 45. Now, each one of these four pieces, every single one of them, is in the unit circle, right? So I can find out what they're equal to. For instance, the cosine of 45 is √2/2. And oh, by the way, the sine of √5 is √2/2. If I wanted to find the cosine of 30, wouldn't I be looking for the x coordinate on my unit circle where the 30-degree thing is? Imagine 30 degrees. And you would come up with √3/2, and the sine is a half. These two get you, when you multiply them together, √3 times √2 gets me √6/4. These two get me √2/4. Final answer, root 6 plus root 2 over 4. And that's how you would do one of these types of questions. Is there any question about that? Do you feel comfortable about what I just did? I know a lot.
I was wondering if you can do like
Mm-hmm.
in the homework problem, it said sine of like 185.
Okay.
Oh no, 165. I was
165.
really confused on that one.
Right. It's the same question. It's probably you just can't think of an angle that works. Right. Imagine you got your unit circle here. And these are degrees, right? So what would you go? You go 30, 45, 60, 90. But there's still some guys over here, right?
Yeah.
You could get 150 would be that one. That one there would say 135. This one here says 120. And then there's lots of guys in the bottom. I'm just going to focus on the top because I can tell you where these two guys are coming from. 165 is pretty big. So I'm going to think of 120 and 45. Right? You agree that adds up to it? Now,
Yes.
if you're really lucky, you might be able to find another couple of angles somewhere else that does the same job. And that's fine because it's hard to get, but occasionally it might happen. And you're good to go. Sometimes you might be able to get two angles that add up to 165 or two angles that subtract one from the other. I mean, I've seen that happen too. Now, when you do the sine of A plus B, that's a different formula. It's the sine of A, sine of B, plus the cosine of A, sorry, sine of A, cosine of B, plus the cosine of A, there we go, sine of B. So in this case, it would be the sine of 120 followed by the cosine of 45 plus, you know, the other two. And each of these four fellas would be a unit circle thing. And you end up with ugly looking fractions almost always that look something like that. Did that help?
Yeah, that helped. Thank you.
Right. So it's not a guessing game here. I don't just say, oh, my brain just told me it's 120, 45. You could do it that way. I mean, if you're really stuck, here's a slow way of eventually getting it. 30 plus what gets me 165? Well, 30 plus 135. Oh, I just got another correct answer. 30 and 135. 60 and 105. That's no good, right? 90 and, what would that get you? 90 and 75. That's no good. So basically, I'm picking this guy, and I'm seeing what's left. And if what's left is also in the unit circle, use them. Now, that's quite a laborious thing, but I guess if you really, really get stuck on one, just start at the first angle and say, okay, 30 plus what would give me 165? Is the second piece the plus what in my unit circle? Yeah, great, use it. If it's not, throw it away and move on to the next one until you find the one that works. One of them will work, either as an addition or as a subtraction, or else the question's not really fair. Okay, so that was one group of questions that talk about finding the exact value. And there is a whole batch of similar questions with degrees. But this one here is question 4 or something similar. And it's the same question, but with one major difference. Can you see its radians? If that wasn't bad enough, it's a negative 7/12 pi radians. Now you're going to try and imagine two angles added or subtracted give you that. Well, pretty much Why do I know it's got to be 2 guys subtracted? Just looking at it, I know it has to be 2 things subtracted. Has anyone got an idea of why I can say that?
For that, I can't think of anything that like adds up to it. So
Right.
that's why.
If the answer is negative, don't you have to have something take away something to get a negative? You can't add 2 things and get a positive. That's all I was getting at, right? So I'm going to be thinking A take away B. I'm trying to just visualize what my thought process is for this question. So I know it's a subtraction. Do you know I know something else? Isn't the first guy going to be small and you're going to take away something bigger?
Yeah.
And I know that because the answer is -7/12. Now, when I look at my unit circle, I don't really get the things written in a very easy to see way. Because one of the things is that when you do a unit circle and its radians, isn't everything in various weird fractions of pi? So what I would do in this question here is I would take my unit circle and I would realize that this guy's the same as 2/12. But I'm not going to write the pi next to it as a distraction, but pretend it's there. 1/4 is 3/12. 1/3 is 4/12. And if you do this fella here, which is 2/3, you get 8/12. If you do this one, you get 9/12. If you do this one at the end, you get 10/12. If you're wondering, as you go through this kind of anti-clockwise direction, if you turn everybody into 12ths, then it's a little bit easier to figure out which 2 differ by 7. Right, 2 of these guys, if you take one and subtract the other, you get the answer 7/12. And it's only from the 6 that are there. Can you see which of those 2 guys are going to work?
Pi over 6 minus 3 pi over 4. Well, I did the original.
Cool. So you've seen this question before? Or you just saw it right now?
Just saw it.
Well, you got it right. Can you see, since they're all 12ths, you can kind of forget about the 12ths, right? And they all have pi, so you can forget about the pi's. Do you know you just need to focus on the numerator now and say, what 2 guys subtracted give me 7, right? And 2 take away 9 get me 7. Now, although that's what we used, that's what it becomes. And then you would do the sign of A take away B formula and get all the exact values. And it's always going to be, I'm making this up. It's going to have that kind of look to it, right? Some ugly fraction, but all of them are. I know that's not correct, so I'm scrubbing it out now. So when you're looking at this question, find the exact value. It's going to be a unit circle, 2 angles added and subtracted. Some combinations got to work. Pick the right formula for it. In this case, if it's the sine of A minus B or cosine of A plus B, then you're good to go. And that kind of takes me, at least as I scan through these questions, that takes us to about question 7. So if we move on now and we look at an identity question. This is question 8. And we're being asked to show that the cosine of x take away pi upon 6 minus the sine of x plus pi upon 3 equals 0. Now, the only difference between a simplified question an identity question is, then a simplified question, you don't know what it simplifies down to. In an identity question, they tell you. So here goes. This fella here is like the cosine of A take away B. This one here is like the sine of A plus B. So if you take this fella, you get cosine A, cosine B, minus sine A, sine B. How do I know that? There is a whole bunch of formulas to do with sines and cosines of A plus B and A minus B, and you probably should write them down on a piece of paper and have them beside you with your unit circle when you do this section. Then it's going to be take away, so a bit of big bracket around it, the fella sine A plus B. So that's sine A cosine B plus cosine A sine B. Now A is going to be X and B is going to be pi over 6. And then you put this fella in and you're going to get sine X times cosine of pi upon 3. Add cosine of X times the sine pi upon 3. And basically you calculate these fellas here because they're going to be exact values. And the bits that are here will cancel out the other bits, and about 3 lines later, you'll be able to prove it's 0. So you're given this, you convert it into its long expanded form, and all the pieces eventually will cancel out, at least in this example. Have you any questions about that? Okay. And let's move to the final kind of questions from this section. And this one is question 12. We've been asked to evaluate the sine of theta plus phi. So that's what you're going to get the value for, the exact value. And you're being told that the sine of theta is 8/17 and that theta is in quadrant 1. And you're also being told that the cosine of phi is -2 root 5 over 5 and that the angle phi is in the second quadrant. Now this one question is going to take a lot of work. It's not a go to your unit circle and you're done kind of thing. This is going to involve you seeing a whole load of different features all put together just to come up with this guy. Now, if you think of that as A and that as B, I can split this up into the sine of A, which is this fella, times the cosine of B, plus cosine of A, sine of B. Now, I happen to know that the sine of theta is 18/17. What I don't know yet is that guy. And I know the cosine of phi is -2 root 5 over 5 times the sine of phi, but I don't know him yet. So if I can find out what the cosine of phi is and what this, let's take that back. We know cosine phi. What I don't know are these two fellas. So as soon as I can find out what the cosine of theta is and the sine of phi is, I'll multiply them two and it'll join these two and we're done. So let me go back to this fella. And I'm going to use this fella to get the value of that guy. And the way we're going to do it is bringing back some stuff that you haven't used for a while. Can you remember SOHCAHTOA? What is the sine of theta in SOHCAHTOA? That's scary. No one remembers the sine of theta, or the sine of any angle. Theta is not important. And you're depressing me. SOHCAHTOA.
Should opposite over hypotenuse?
Yes. I wonder if you thought that I was giving you a trick question. Maybe that's what you thought. That's all I was asking. SOHCAHTOA, what is the sine of theta? So maybe it's a little bit more clear now that you know what I was getting at. Right, now if I draw a little right angled triangle and I'll make this theta, then this guy here is opposite. And he's 8, because the top is 8. And this fellow over here is a hypotenuse, so he's 17. The only thing I don't know yet is the adjacent. And the cosine is the adjacent over the hypotenuse. If I know that this guy here is 17 and this side here is 8, how, you don't need to tell me the number because I'm pretty sure it's an ugly number and I'm going to have to figure it out in a minute. But how are we going to get that third side? And I'm wrong. It's actually a nice number. If you know two sides of a right angled triangle, don't you find the third side by doing a particular thing after a Greek guy who starts with P?
Pythagorean theorem.
That's what I was getting at. So I'm trying to get used to thinking. If all you do is, yeah, he said that, I'm writing it down, then you're not really thinking hard enough, because what you're going to do the next time you see a question, you're going to say, I think he done some by unit circle and he magically brought out two numbers. Don't know what he did. I just wrote down what he said. You're not going to get the same kind of benefit from it than you do. So everything involves, a little bit of thinking. If you can think it through as I'm doing it, then it is going to be of help to you. Well, anyway, this guy becomes 15 over 17. And now I'm going to ask you one more question. Up here, you were told that the angle was in the first quadrant and the cosine is adjacent over hypotenuse, so the number is 15 over 17. The only thing I need to do now is find out if it's positive or negative. In the first quadrant, is a cosine positive or is it negative?
Did you ask for the first quadrant?
Yes, I did.
It's positive.
Correct. Now, see if up here they had said it was in the third quadrant, then the cosine would have had a negative next to it. And the reason why that's important is if you have a number and it's positive or you change it to negative, isn't your answer going to be a little bit different? And so you need to know what the right one is. So after all that hard work, we've just figured out that this guy is 15/17. Right, you're going to get a quicker version of the second one. I know that the cosine of phi is -2 root 5 over 5. I know that that means the adjacent of the hypotenuse, because that's SOHCAHTOA. I'm going to draw my little right angle triangle. I'm going to have an opposite, a hypotenuse, and an adjacent. The opposite is 2 root 5. The hypotenuse is 5. If you use Pythagoras with this number and this number to get this third side here, let's say 25 take away 20, this fella here ends up being root 5. I needed that so I could find what the sine of phi is. And the sine is the opposite of the hypotenuse. Oh dear. If I had a brain, I'd be dangerous. Adjacent over hypotenuse. Now I've labelled it right, we're still good. It's going to be root 5 over 5. I called that. I said adjacent over hypotenuse and I put the wrong number there. But I fixed it. It's now correct. Oh, last question. Phi is in quadrant 2. So if you've got an angle in the second quadrant, will the sine be positive or will the sine be negative? Second quadrant sine. All sine, tan, cos. I wonder if we might have a microphone problem. Okay, Nikki, can you hear me? Nicole, can you hear me?
Yes.
Okay,
Sorry.
so that's good. Amaya, can you hear me? Grace, can you hear me?
Yeah, I can hear you.
Okay, so that's not the reason I'm not getting an answer then. Okay, so one last time. I mean, I can tell you this answer. I could have told you it 5 minutes ago. And what I'm trying to get you to do is think this through, because if you don't know it right now, how are you going to know it in 5 minutes from now? Right? And it's picking up something that maybe you need to spend more time on than you think. Because all these things take up time. When you're doing a test, if you have to say, oh, I'm going to have to find out what sine the sine is in the third quadrant, all these little things are going to take you away from your brain. So one last time then, if you are a sine function and you are in the second quadrant, are you positive or negative?
You're positive.
Yeah, that's all I wanted. So you put the whole package together and it's positive up here. So what we got, this guy times this plus this guy times this. Right. If you multiply these two together, you get negative 16 root 5 over 50 and 85. And then you multiply these guys together, you get this guy also over 85. But that guy and that guy, you end up with negative 1 root 5 over 85. And that would be the end of that question. So anyway, I hope you don't think I'm picking it on you. I'm not trying to be that way. But it does concern me that you either don't know the answer, which does concern me, or you're just shy and you don't want to tell me, which isn't a big deal. Okay, we're good with that bunch of questions. Is there anything else from the addition subtraction world that you would like me to go over that I may not have covered? Because the next part of today we're going to look at is the last section, which are the double angles in product to sum ones. In a lot of ways, they're going to be quite similar.
Can you do number 10?
Question 10. So we're talking, is this 10 about from that section that we're still on?
Yeah.
Okay. Give me a minute, I'll find it. Oh, it's an identity one. That's a good one to finish with. You're being asked to take the sine of x plus y, subtract the sine of x minus y, take the cosine of x add y, and take the cosine of x take away y. And we have to show that that entire thing, the whole thing, ends up being like that. Now, this question could have simply just been, simplify that, and the answer you put in the box would have been that. So that's the only difference. So let's see. If you look at the formula for the sine of two things added, it's the sine of x cosine of y plus the cosine of x sine of y. Subtract, a little bracket around that. Yeah? The sine of x minus y looks almost the same, but has a negative in the middle. So you're going to have a sine of x, a cosine of y again. Subtract the cosine of x sine of y. Now that's one pretty ugly looking expression. Now the cosine of x add y is cosine x cosine y. Take away sine x sine y. And for the other fella, it's a cosine x cosine y plus sine x sine y. If you look at these two formula, they look kind of wrong. You see that when you add, you subtract the two terms, but when you subtract them, you add the two terms. It just looks wrong. Right. Sine of x cosine y gets killed off by that one. This guy, take away a negative, ends up, you now have two of them. This guy here gets killed off by this guy here. Cosine xy plus another cosine xy gives you cosine of x, cosine of y. The 2's cancel, the cosines cancel, and you are now left with sine of y over cosine of y. And that guy is your tangent. It's a very quick version, but you get the gist of the process. You find the sine of a plus b, or whatever the letters in the textbook have, and you've got that guy. And you plug everybody in for what he's worth, and a whole load of things get killed off, a whole load of things get cancelled, and then you're left with something very nice at the end. Okay. So, ready for the double angle one. For the time I've got left, I'm going to skip by some of the early ones. I'm going to go straight into a pretty standard question. Let's suppose that you've been told that the sine of x is negative 3/5 and that x is in the third quadrant, and you're being asked to find the exact value of the sine of 2x, the cosine of 2x, and lastly, the tan of 2x. Okay? I'm going to begin by using this piece of information, and I know that the sine is the opposite over the hypotenuse, and I'm going to draw my big right angle triangle, call that their angle x. I wish they'd called it theta. I like angles to be called theta, because if you call them x, it feels like it's something to do with the x-axis, and it's not. And this particular guy then, the opposite is 3. The hypotenuse is 5, and the adjacent ends up being 4, because I use Pythagoras. Now you might say, what happened to that negative? When you build your right angle triangles, the negative doesn't matter. Just ignore it. It's just positive numbers everywhere. So don't think about putting a 3 or a negative here or here. It doesn't help. So now we can move on to the sine of 2x. Yet another formula. The sine of 2x can be written as 2 sine x cosine x. That's going to be 2 times the sine of x, which is 3/5, times the cosine of x. Well, if I look at my little triangle here, the cosine is the adjacent over the hypotenuse, which means that it is 4/5. But, and it's a big but, the angle is in the third quadrant. So cosine x is an angle in the third quadrant. And in the third quadrant, the cosine is negative. So you put all that together and you get positive 24/25. So there's one of the 3 answers. Now, if you want to get the cosine of 2x, use another formula. Trig is full of formulas that you just, it saves you an awful lot of time if you can just memorize the darn things. Otherwise, you're going to have pages of formula that you keep skipping through to see which one you're really looking for, because you can't quite remember what it is. So this is the cosine one. The cosine of x is negative 4/5, but then you square it. The sine of x is negative 3/5, then you square it. That guy is 16, that guy is 9. So the answer, 7/25. I'm running short of room here, so I'm going to put it here. If you wanted to find the tan of 2x, I could actually go and find a formula for the tan of 2x. There is one, but I'm not going to use it, because if I've already found the sine and cosine, then I can use those numbers. And the sine is 24/25, and the cosine is 7/25, and a little bit of cancelling. There's your last answer. So from just being told what the sine is and the quadrant that the angle x is in, you can find all these what are called double angles, the sine of 2x, the cosine of 2x, or even the tan of 2x. That's pretty cool. Any questions about that? Okay, let's make it harder. Not going to do the whole question this time, I just want to show you part of it. Suppose it was the same question, find the sine of 2x, cosine of 2x, tan of 2x. But the piece of information they gave you was that the sine of x is 3/2 and the x is in, say, the first quadrant. They always do that. That guy is not very helpful for right angle triangles. So I'm about to give you one of my, hopefully not long pause questions. If the secant is the number or fraction 3/2, what's the cosine of x as a fraction?
Two-thirds.
Yeah, that wasn't too bad. You remember that secant and cosecant are just reciprocals of each other. Right, now that means I can now do adjacent over hypotenuse, which makes this guy 2, makes this guy 3, 3 take away 9 take away 4, and that guy's going to be, I believe, square root of 5. And now you can find the sine of 2x, the cosine of 2x, and the tan of 2x in the usual way. Are we good? Any questions so far?
I don't have any questions.
Okay, we only have a few minutes left, so what I'm going to do, if you can bear with me for a few moments, is I'm going to go in and show you all those formulas and where you would find them in the ebook. And maybe you could, if you've got a printer, print them off. If not, you could probably, it would be of good benefit to write them down. And it's in here somewhere. Here we go. Oh, picked the wrong one, sorry. There we go. Got it now. Okay, so yeah, let's share screen for you. Here we go. So what you should be looking at here right now is the double angle half armor formula shape. I'm assuming that's correct. So if we zoom up here, you're going to see, well, this goes really quick. These are the identities, which we haven't done today. Here we go. Just a bit bigger. Here are a whole load of formulas I've been using today for the sine, cosine, and tangent, right? So today, you know, I've been zooming about. I've been calling them A and B, and they've called them S and T, but that's just cosmetic. And they have good examples there. If you want to see more examples of that process being done, I strongly suggest you do that. Now, if we zoom to the next bunch, there's the cosine, the sine of 2x. I used that today. And here's the cosine of 2x. There's 3 versions of that. I would probably only worry about, you know, remembering one. And that's the tangent of 2x if you want to use the formula. If we move a little bit further down, these are formulas that you use if you want to rewrite sine squared in terms of, say, cosine 2x. And last but not least, these guys. These are the half angle formulas. So if you get a question that says, I want to find the exact value of the sine of 15 degrees, right, one of those questions, or the exact value of the cosine of 22.5, and you're to use a half angular formula, I'll show you how that would work. If this guy was 15, that makes this guy in here 30. So the sine of 15 would be 1, take away the cosine of 30 over 2. So whatever angle you find the exact value of, twice that angle goes here. And you're good to go. The reason why it has a plus or minus is for the same reason that you have all of them. If the angle you're trying to get is in the first quadrant or the second or the third, it might be positive or it might be negative, and it depends on your quadrant. Whew, we made it. A lot of stuff covered today. I hope I've been of some help to you. I guess my last piece of advice is get a hold of all these formulas and print them out, because every question is going to, virtually every question is going to use them. And if you don't have them somewhere handy, it's just going to slow down, you know, the amount of time that you're going to take to do a question. And certainly next week when the test 3 comes round, you only have a limited amount of time to do your test. You don't want to be spending half of it trying to find a formula. So if you have them handy, that would be a really good idea. And any questions for the good of business, because we're going to finish? Okay. Have a nice weekend. I will, as always, if you have any problems, shoot me an email. If that's not going to work, we can do a quick one-to-one Zoom, and hopefully solve your problem quickly. Okay, everyone. Bye-bye. If anybody has a one-to-one question, you could wait till the last one out, and then I could maybe do that. Bye, Nikki. Bye, Nicole. Alicia. And bye-bye, Amaya. You're the last one to leave.